Hello, welcome back. Today we're going to be looking at some algebra review, and we're going to start with this idea of something called a function. Now, a function tells you that each x is going to be paired with exactly one y. So if you have an x, you're going to have one y. X values cannot repeat, and something called the vertical line test can be used to determine whether a relation is a function or not, and that's used on a graph. So if you look at our graph right here, you'll see that they're using the vertical line test, as the words state, and they've drawn a vertical line, and it's crossed this parabola. I'll outline the parabola in red. It's crossed it twice. Once, twice. The vertical line test tells us that if you can draw any vertical line, and it crosses through the shape more than once, it is not a function. So if we take a look at another example, you'll notice that in this graph, it is a function, and what they've done is they've drawn a lot of vertical lines to demonstrate that not a single one of those vertical lines crosses through the shape more than once. Notice that all these vertical lines just cross through that graph only once, which means that this, yes, is a function. So here's a typical type of problem that you might be asked using the information we just got through learning. Which of the following tables does not represent a function? And they give you some x's and they give you some y's. Remember, your x values cannot do what? Well, they cannot repeat. So it's pretty easy. If it says does not represent a function, well, if x values can't repeat, in order for it to be a function, that means if your x values repeat, it is not a function. So all you gotta do is look A, B, C, or D, which one has some x values repeating. Go ahead and take a look. You'll notice on choice C, the x values repeat. You have a 1 and a 1. One goes to 1 and one goes to 16. So therefore, answer choice C shows us a table that is not a function because the x values repeat. To give you an idea of what a function is, we're going to take a look at something called a function machine. And what happens is you throw something into this machine. This is our input, and there are x values. And out comes a y value, or your output. So you put something in, your x's, and you get something out, your y's. Now with this whole idea of functions, there's this idea also of dependency, something depending on something else. So what we're going to do is we're going to take grades and study time, we're going to make a statement using the word depends on. We're going to go working out and losing weight, and we're going to use another statement using depends on. So what depends on what? Do grades depend on study time, or does study time depend on grades? Well, your grades typically depend on the study time. What about working out and losing weight? Which one depends on which one? Does working out, the amount you work out, depend on how much weight you lose? Or does the amount of weight you lose depend on how much you work out? Well, the amount of weight you lose depends on how much you work out. The thing that depends, such as grades, this is your dependent variable. So in this case, which one's the dependent variable? Is losing weight dependent, or is the amount you work out dependent? Well, losing weight is the dependent amount in this example. Excuse me. So we're going to take a look at what the independent and dependent variables are and how they deal with this thing called a function. The independent variable is the input of the function machine. So the thing you're sticking into the machine is the input. It is always represented by the x variable and is always on the right hand side of the equation or last in the equation. Now the dependent variable is the output of the function machine. It'll always be graphed on the y-axis and it will be on the left hand side of the equation. So we're going to take a look at a couple of examples about independent and dependent variables using what we've learned so far. Go ahead and read this example and see if you can find out which quantity is dependent in the statement. So Rhonda works at a grocery store after school. She's paid $5.50 per hour. Her weekly salary is S, described by the function S equals 5.5h, where h is the number of hours she works in a week. What is the dependent quantity in this functional relationship? So if you remember, dependent is always on the left-hand side of the equation, or always first. So your dependent quantity is S, because the salary depends on the amount of hours worked. So what's the dependent quantity? Is it the number of hours she works? Well, no, the hours she works does not depend on the salary. The number of dollars she's paid per hour, well, that's a fixed amount. It's $5.50 per hour. That doesn't change. The total salary per week, now that is the dependent quantity, because you'll notice that S stands for her weekly salary. So her weekly salary is the dependent quantity. Taking a look at another example, go ahead and read through this one, pause the video, see if you can find the answer, press play when you're ready to see the answer worked out. Alright, the length of the spring when a weight is attached is determined by the equation L equals 0.4g plus 15, where L is the length and g is the weight in grams. What does the dependent variable represent? So we look at it again. Dependent means the first or the left-hand side of the equation. So it is our L, and that makes sense because length should depend on how much weight is being attached to the spring. So L is our dependent amount. And what does L represent? L is the length. So we read through the answer choices. We see that the maximum length of the spring is a choice. Well, that has to do with L, so maybe. The length of the spring when g grams are attached. So again, we're talking about length in two of these, so I'm going to say another maybe. The number of grams of weight. Well, no, because g is not the dependent amount. And the amount of change in length. I'm going to say another maybe. So we have three maybes and one that definitely got crossed out. We just need to figure out, what does L stand for? The length of the spring when a weight is attached, and L is the length. So does it ever say anything about the maximum length of the spring? No, not really. So A is not an answer choice either. Does L represent the length of the spring when g weight of grams are attached? Absolutely. So B is looking a lot better right now. I'm going to go ahead and circle that, but let's be careful and go ahead and read D again. The amount of change in length. Does L represent the change in length? No, L is just the length, so D is not the answer either. Now that we've taken a look at some functions, we're going to take a look at matching equations with data. Now, an equation, by the way, functions can be represented as equations, usually. Equations can be represented in these ways, as graphs, tables, or ordered pairs. Now, if we're given a table, there are two ways we can go about working a problem. One way is if we're trying to get an equation, we're going to go through these steps in the calculator. We're going to go stat, edit, and then stat calc 4. However, it's almost always easier, given an equation, they may be multiple choices, to put the equation or equations into y equals, and then go second graph, which is your table. Now here's an example of a problem that you might see trying to match a table with an equation. A personal trainer at a local gym charges the following fees for a 1-hour training session for 1 to 4 people. One person $20, 2 people $24, 3 people $28, 4 $32. The question is, which equation best represents the relationship between n, the number of people, and c, the cost? So all you really need to do is find out which of these equations, when you substitute in 1 for n and 20 in for c, will give you a true statement, or substitute 2 in for n, it'll give you 24 for c, 3 in for n, 28, 4 in for n, 32. Now that's a lot of math to do. There is a faster way, and that faster way is to grab your calculator, go to your y equals, type in the equation, except we can't use n and c, so I'm going to call this one y, ny, and cx for that first example. And I'm just going to type it in exactly what it looks like, x plus 19. And I go to my table, which is second graph, and I see if my table matches theirs. You'll notice the tables don't match, so the first answer choice isn't it. So we go to the second one, 4x plus 16. Now notice for this one, we're changing the letters. That's okay. We're going to call c, y, and nx. And we go to our table. 120, that matches. 2, 24, that matches. 3, 28, matches. 4, 32, that also matches. So you'll notice that B is the correct answer choice. Again, the quick way to do that was just to go to your y equals, type in the equations one at a time, and go to second table to see which one actually matched the table that we were given. Now here's a question where we're going to try to match a graph with an equation. So you could remember your whole rise over run, slope intercept thing, or another option is we're going to match this graph with the equation by getting our calculator, going to your y equals, and just typing in the equation, 5 divided by 2x plus 6. We press graph, and we're going to see if this graph matches the one we're given. You notice it does not, so that means A is not the correct choice. So then we go to B, perhaps. We get 2 divided by 5x plus 6, and we press graph. You notice this graph doesn't match the graph we're given either, so let's try C. Perhaps C will work. Go ahead and try C on your own, graph it, see if it matches. Press play when you're ready to see the answer. So for C, we typed in the equation, and you get this graph right here. You'll notice that not a single one of the graphs match the graph that we're given, so the actual answer is not here. If any one of our graphs matched the graph we were given, that would have been the answer choice. Now we've matched equations to graphs and equations to tables. Now we're going to try to match graphs to verbal situations. So verbal meaning you just got a bunch of words and you got to figure out what this is actually describing. This is going to be tricky, so be careful and read your graphs carefully. How they label the graph is very important because they're going to try to trick you. Okay, so Karen is jogging at a steady pace in her neighborhood. She then runs down the hill, and her speed increases. Which graph best describes the situation? Now, we look at the graph. Again, first things first, read the graph. Up and down is speed, and left and right is time. So which one of these graphs shows a steady pace and then an increase in speed? Now, I don't care about the hill. Doesn't matter. Because only thing our graph's going to tell us is speed and time. So as time goes on, which one shows, again, a steady pace and then an increase in speed? Well, the first graph, A, doesn't fit the situation because the speed doesn't start off steady. So A is not an answer choice. If we go to B, again, speed isn't steady, so it's not an answer choice. C, you'll notice the speed is steady, and then the speed decreases. Well, that doesn't match because our speed should increase, which leaves us with D, steady speed, and then an increase in speed. So now we've got another situation where you've got a very long verbal description and another graph, and we're going to have to match the graph to some answer choices here in a second. First thing, again, just read through the problem, then read your graph. Be real careful, make sure you're reading your graph, and then slowly read through the answer choices once we see them, and we'll see which one actually works. Now, a ball is thrown straight up in the air from a roof of a 192-foot building, so we're starting off how high? Well, we're starting off at 192 feet tall. And it goes at an initial velocity of 16 feet per second. Assuming no air resistance, the height of the ball at any given time is given by this long function here, where h of t is the height of the ball and t is the time elapsed in second. The graph of the function is shown below. So think about the situation. We've got ourselves a graph here, height in feet and time in seconds, and a ball's being thrown off a roof. So notice our ball starts here, goes up a little bit because we're throwing it up, and then comes down over time. So we're going to use that graph, and we're going to see which of the following situations matches. Now, I can't show you them all at once, so we're going to read through them one at a time, and I'll delete the ones that don't match until we find one that does. So, starting with answer choice A. Does the ball return to the height of the roof after 1 second? So here's 1 second right here. And we got to think, where did the ball start? Well, it started at the roof. So you'll notice that it actually started at about 190 feet, and after 1 second, it did reach its initial height again. So pretty easy. First answer choice actually checks out. If you saw the second one instead, the height of the ball increases at all times. Notice the height's not increasing at all times, so that second choice would not work. Again, A was the correct answer. The ball fell at a constant rate between 0 and 4 seconds. If we look at 4 seconds here, you'll notice the ball's not falling at a constant rate. It actually looks like it's falling faster and faster. And the last one, the ball returned to the height of the roof after 4 seconds. Well, after 4 seconds, the ball is at 0 feet high, and the ball started on top of a roof 190 feet high, so that one wouldn't work either, which means our correct answer was our original one, which was A. The ball returned to the height of the roof after 1 second. So we've looked at equations. Now we're going to look at inequalities. Now inequalities means you're going to have these little symbols, the greater than or equal to, less than or equal to, etc. So the greater than, this little symbol right here means it's greater than. Sorry, greater. This is greater or equal. Now, the greater than or equal to is going to be the triangle facing up in your calculator. And it's going to look like this. And I'll show you what that means here in a second when we work through an example. This is less than or equal to, and it's going to be a triangle facing down in your calculator. Now, let's see if I can't get that to look exactly like the calculator. It'll look like this. Now you notice it makes an L, so that's a good way to remember that it's the less than symbol in your calculator. Greater than or less than means a dashed line, and it isn't a solution. Greater than or equal to, less than or equal to means a solid line, and it means it is a solution. Sorry about that blank right there. So what we're going to have to do is we're going to have to match an equation or an inequality with a graph. First thing we're going to do with that inequality is we're going to want to turn it into an equation where it's just y equals. So we're going to have to take our x minus 3y greater than or equal to 12, we're going to have to turn that into just y is equal to, so we're going to subtract x from both sides, giving us negative 3y is bigger than or equal to negative x plus 12, dividing both sides by negative 3. And there was this rule you need to know about inequalities. It says if you divide both sides by a negative, you have to flip the direction of the symbol, giving us x over 3 minus 4. So this is the equation we're going to put into our calculator. Y is equal to, or less than or equal to, x over 3 minus 4. So we grab our graphing calculator, turn it on, go to our y equals, clear it out, and we get what again? X over 3 minus 4. So we go x divided by 3 minus 4. Now, if we go back to our equation, you'll notice that it is y is less than. So what we're going to do is we're going to go, and less than what made an L, we're going to go on top of this little line right here where it's blinking and press enter on it until we get a triangle facing down, or a triangle that makes an L symbol. And when we graph that, we get this line that looks just like this right here. Now the good news is, all we got to do is match the equation in our graph, now that we got it into our calculator, match it with one of the answer choices we're given. Is it A, B, C, or D? Now, it's pretty obvious that it has to be answer choice A, because it's the only one that really looks like the graph that we were given. So A is the answer.